Start.
So let's go ahead and get started. This will be the end of what's been a very interesting day for me. I know it's getting late and people are getting tired. We have another fantastic panel of experts who have some science and some information systems and some technology expertise, but that's not what they're here to talk about. We're here to ask them about the societal impacts, business impacts, and things like that. So I'll let them introduce themselves. I'm sure everyone recognizes Vijay though, so I just wanted to point out, in case you didn't realize, he is the co-chair of this whole ICRRIA conference with, how many people are here, Vijay?
4,108.
4,108 people, so thank you so much for doing that for us. Appreciate it.
That's another 2,000 online.
Right, that's amazing.
Who's counting?
Wow.
And so with that, I'll ask you to introduce yourself, starting with Nicole.
Yeah, hi everyone. I'm Nicole Barger. I'm a professor in the Department of Ecology. So I'm a kind of alien life form here, ecology and evolutionary biology at the University of Colorado at Boulder. And as an ecologist, I work on organisms and how they so I'm a biologist, how they interact with each other and how they interact with their physical environment. So within that discipline, I work on restoration ecology, and that's why I was pretty excited to be here today. So I work on, taking my ecology skills on questions on how we restore degraded or damaged ecosystems. So the other part of my life, and this is another thing I'm very interested in, is I work with the United Nations at the Science Policy Interface with one of the conventions. There's a climate change convention, a biodiversity convention, and a land convention. So I've just returned from the Ivory Coast from one of these big conventions. So I have some of those ideas in my mind right now of what's really important in terms of what we need to be addressing in the world right now. So the reason I got here is that I collaborate with two robotics research groups on restoration, using robots for restoration, specifically not in forests, but in specifically in dry land and rangeland ecosystems. So I think the most important thing to say is that 70% of the land surface right now has been altered by humans. So we're basically stewards of a massive amount of our land systems globally. And so some of what we do over the next 10 years is pretty critical. So if you listen to any of the environmental news coming out of any of the climate change convention, is that we have about 10 years to respond. We need to act now, and we need to develop technologies now to deal with our pressing issues of climate change, biodiversity loss, and land health. So I'm really excited to spread that message to all of you, because I think we need an army of people to take on we're now in the UN Decade of Restoration, which started last year. So the goal is to restore ecosystems that have been degraded to at the spatial extent of the size of the US or China by 2030. So 100 billion hectares by then, and then 5 billion by 2050. So we just need a huge army of solutions at different levels. So yeah, with that, that's me.
Perfect, thank you. Thank you.
I have nothing quite so robust. It's like, I am not worthy. So I'm the director of GIS at TreeSwift. I just started that position in February. Before that, I've spent 25 years in a TIMO, which is a timber investment management organization. Those pretty much came about as a result of large forest companies selling off their land assets. And so REITs and TIMOs kind of came into being, kind of gobbling up all that land. Somewhat interesting, somewhat comparison to robotics in forestry is that GIS, which is my specialty, was a relatively new concept, and you had a lot of foresters who were used to using paper maps and gazetteers, and kind of like, what is this newfangled GIS? And so basically, I started learning it at the beginning of my career, and we were pretty much set up at an enterprise level after 25 years, and the whole concept of GIS in forestry is sort of, you couldn't take the smartphone or the iPad or the GPS away from a forester at this point because they can't do their job without it. And but it was a process, and I think robotics is also going to be a process. I don't know if it'll take as long, but it's still a process. So I'm real excited about working with TreeSwift because this is just fascinating, and I think that what was very satisfying for me was to bring GIS into the TreeSwift robotics world where they pretty much hadn't thought about GIS much at all. But then being able to use it in the field to be able to verify their results was really, they were like, yay, this is great. So I like the merging of different areas of expertise, different kinds of technologies. And I think that really helps. So that's me.
Excellent. Thank you very much. PJ.
Thank you. I'll try to follow up on that. So I've been doing robotics for 35 years. So why forestry? Well, it's very simple. I think if you look at the average incoming student into any top-notch university in the world, the one thing that they want to change is the status quo in climate. Right? So this is going to happen, and it's an important thing. We've known this for a long time, but as Nicole mentioned, this is it's not a question of when anymore. It's a question of now. And so there's some urgency to this. But the way I started approaching this was not from that standpoint. It was simply to find a test bed for solving some hard problems in autonomy. So the self-driving car industry, I think, has just taken away some of the easy problems. It's all fairly well structured, autonomous navigation and roughly 2D terrain, pre-mapped, and so on. And so the two related areas where I think robotics can really play a role, one is in precision agriculture. I know, George, you've been thinking about this as well, where it's messy. I mean, plants grow and you want to monitor it. And yet we, after, I don't know how many years, we still don't have a systematic way of monitoring plants and administering the right level of inputs to each plant. And forests, you just take it up to a notch in terms of complexity. Again, I'm not talking about the impact. I know you want to get to the social impact side, but it just takes it up a notch. They're just much larger, much more complicated to deal with. The underbrush, the understory, the canopy, and everything. And so for us, this sounded like a great way to have an impact. Can you actually measure and map every tree in the world? And as you all know, 30% of the land surface is covered by forests. TMOS, thanks to TreeSwift, is, by the way, in full disclosure, is a spin-off from my lab. Stephen Chen, the first person to start it, now the three co-founders, is a PhD student, and I'm still trying to get him to finish up his PhD in my lab. So on one hand, I applaud TreeSwift. On the other hand, I said, Stephen, come on, finish up. So I was exposed to TMOS, and I know Elizabeth can talk a lot more about this through Stephen. And it just seemed to me that from a social impact standpoint, if you want to really have an impact, you want to have somebody who pays the bills first. And then it seems that TMOs have a shared interest in conserving forests. Normally you think about how dare you cut down the tree and log it for furniture. But as I've discovered, as Dean of the Engineering School, that actually mass timber construction are much more carbon efficient. The footprint is actually less than steel and concrete. And you cut down trees, they grow back. So if you are able to harvest trees in a careful way, which TMOs actually do, then there's a double win for us. So I started getting interested in this, and then I started also getting exposed to the antiquated ways in which where people measure trees, and the technical panel touched on some of these issues. And I said, here's something that robotics can solve and really have an impact. So I came at it from a very different angle and said, here's a test bed of extremely rich problems, which we can try to solve and also have an impact on the planet. And so it's hard to find a win-win situation that's better than this one. I just want to thank you 3 years pandemic, I didn't know what was happening in ICRA. I come back and there's a panel, there's a whole workshop on forestry. So thank you, George, for doing this. It's good to be back.
Yes, I agree with that one. Great. So let's see. So I have some questions that I'll ask, but they're just a framework, a loose framework to keep us moving. But feel free to go off on any tangents that you'd like. So Elizabeth, I'd like to start with a question for you. You know, what do you think that there's going to be this long adoption curve? Adoption is always a tough sell. You talk about GIS, which seems like a no-brainer, taking 25 years to sink in. So from the concerns of the stakeholders, what are the things we should be thinking about to manage that adoption curve? Like, how do we develop, what kinds of problems should we be solving? How should we be presenting the solutions in ways that are likely to be accepted by the various stakeholders? And if you want to take an aside into your take on who the stakeholders are and what they care about, that would be great to hear about too.
I think that, and I sent you that statistic, that most of the forests in this country are privately held. And there's a lot of, so policy making is not necessarily, unless it's taxation or something, it's not going to affect the decisions of private owners. A lot of those privately held properties are generationally held, so that they hand them down through the families. There's a fair number of the private landowners who very much look askance at TIMOs and REITs, because TIMOs are by and large sustainable. They have to be sustainable in order to get the investors, because they're considered a green portfolio play. But they don't hold the properties for longer than 10 or 15 years, because it's a financial instrument. A private landowner is going to be holding it for 20, 30, 100 years, depending on how long they've been in the family. And so I think that when you're looking at forestry, ways of adopting things, you have to think about that private landowner, how they're going to look at something. And they've got very sharp pencils. They're going to look at the cost. And it was just like GIS, which was a no-brainer to me, but it's kind of like, if I can go out there with my map and do what I've done for the last 50 years, why do I need you? So the why do I need you needs to be something that's pretty darn obvious. And it's not like, well, so you don't have to even go in the forest. It's not the answer you want to give to a forester or an ecologist. I mean, you got to get out there. You're going to see more stuff than what can be measured by the robot. So it's like, figure out what it is that is going to be taken away from the arduous, repetitive data collection component that would help the forester, that would cut their costs, that would give them more data, would give them some advantages, being able to use this data and hook it up to better imagery from, say, planet, better imagery from satellites, things like that. So I think that the audience is savvy, but it's also not like, it's going to be very individualized, if that makes any sense.
So these TIMOs, do they have their own, like, do they harvest their own lands, or do they bring in people? Like, are there separate companies that do the harvesting, and the TIMO just kind of is like a trust that manages it?
Some TIMOs are fully like ground up, but most of them use forest consultant shops. Your forestry consultant shops are probably your biggest audience, because they're the ones that get hired by companies like TIMOs or REITs or family businesses. They hire a forest manager to come in and manage their forest. If the forest manager is convinced that this approach makes the most sense, they will put it out there. But so that's the group that probably should be looked at.
And I would imagine these are pretty long-term relationships, the forest manager and the TIMO.
But yeah, forest manager, TIMO, family, I mean, even family farms have forest managers. So there are a lot like AFM or Prentice and Carlisle, or is it Prentice and Carlisle? Yeah, I mean, there's just a lot of different forest consultants. Wow, Landvest. My mind's gone blank all of a sudden, but yeah, there are a lot of them, but they're the ones that do the basic consulting to the owners. Not that some owners do everything, but most of them hire a consultant.
And what about like federal and state managed land?
I was going to just add to just one thing that you said, but the George, I think you might appreciate this. So if you think about robotics solving a problem, right, from the perspective, it's always a bad idea to push a new technology to a new problem. The best way this works is you take an old problem and you push new technology and say, I'm going to give you exactly the same results that you were doing before, but much faster, much better. That's the potential here. Most of us, when we develop new solutions, we're trying to say, this is an awesome solution to a problem that I don't even know exists.
Right.
And then you're trying to sell the problem and the solution, but this one I think is a little more straightforward. Correct me if I'm wrong. So, and I also found the same thing that you mentioned, that they have a sharp fence. Actually, they are a lot more data driven because they're these are financial instruments. Everything that you measure is monetized. So if you do better measurements, they'll respect that and they'll pay for it. Not so in precision agriculture where they're saying, okay, you're measuring this. How do I know it's going to affect my bottom line? That's a new technology for a new problem, and it's much harder to push that.
Interesting.
Yeah.
Right.
Sorry, you were
saying something about
yeah.
state.
Oh, yeah, right. So I'm going off script a little because I'm curious about, so TIMOs are private, and then there's like large amounts of land that's managed by the federal government and state agencies, right? And do the same forestry management companies actually implement the manage of those lands, or is that government as well?
I don't know. I know the U.S. Forest Service has probably got contracts out.
They do their own.
They
do their own
Yeah,
stuff.
yeah. But they do have licensed contractors for certain things like the data collection, like the NAPE. You know, they don't do that. They hire out contractors for that. And NAPE, that's another technology that's evolving. And they're going to be having LiDAR, some kind of like a country mapper that they're going to try and they're the federal government will experiment with new technology.
Right.
And so they do get contacted by firms to try and come up with better solutions.
Right.
So
Interesting. Okay, so let's I want to ask a question of Nicole now. And you know, so you've worked with some people doing robotics in slightly different settings. You've sat through all the talks this morning about all the different sensing and perception that we're doing in these environments. But I'm curious what your thoughts are about the ability of robots to actually take action and do some kind of, you know, large scale remediation or reforestation or range management. Are there applications you see where robotics technologies can play a role?
Yeah, it's a really good question, especially after sitting through the talks today. And something that we really struggle with in our collaboration is that I think the biggest issue, which you probably all know, is scalability. Is that, you know, that statistic before, if we're trying to restore an area the size of the US or China by 2030, you know, what are the technologies that we're developing, you know, here and that we're talking about that can really achieve that, you know, implementing sustainable land management and forest management at that sort of scale. And I think that's going to be the biggest challenge, as having, you know, developing fast enough. And the other thing is that I work and talk with stakeholders from around the world, from sub-Saharan Africa to you know, Southeast Asia, and so that country level context is obviously going to be hugely different to, you know, Western developed countries, and that could potentially invest in some of these technologies. So I think that's what I see is like. So I've mentioned a barrier, but I think also the potential for collaboration and getting, you know, people from like you in this room together with some of the remote sensing experts and geographers, and putting together multidisciplinary teams. And I don't know if this is something you already do, is put together these teams that can truly talk with each other. So from my experience, the last couple of years with working with the robotics research groups is like, it's like I'm learning a new language. And I'm like, I don't know that word, I don't know that word, and I don't know that word. And most of the other words that just came after that. And so we're all like learning an ecology language, a robotics language, and to be able, and that takes time. So that kind of was a wandering answer, but.
So when we think about sort of, what was the word you used? Like fixing, I can't remember what. If we think about, like you said, we need to like restore
Yeah.
a landmass the size of North America or the size of China. I guess there's growing political will behind that. Is there an economic driver? So we just heard about, you know, TMOs and the economic force there that can actually make there be a reason to develop these technologies and get out and do stuff. In the case for restoration at scale, is there an economic driver that's going to push that?
Well, one would be carbon sequestration and mitigation. So that some of the policy changes that we're seeing right now to like pay private landowners and other entities to sequester carbon on their lands, which then has co-benefits for biodiversity, kind of soil health. The other thing is that you mentioned the political will. What we see is pretty significant investment by countries now in the billions. Probably not anything like autonomous cars, but in the billions to start fixing these environmental problems. So in the time that I've been working in this space, the political will and the money that's following that and the commitments by countries to restore and sustainably manage lands is pretty phenomenal. So, you know, and private sector investments. You know, everyone has their own sustainability officer now, or climate and sustainability officer now. So, yeah, I'm hopeful in that way.
Yeah, that's good to hear. It's good to hear. Let's see. I've got a question for VJ here. You know, in the ag space, one of the big issues, I don't know if it's a barrier or it's something people like to complain about, is this right to repair, right? So you have people are used to, they bought the tractor, they should be able to take it apart and do what they ever want, whatever they want to it. And as the systems get more complex and they become autonomous, you know, maybe you don't want them to be able to do that because it might, you know, there's safety concerns. And of course, the business enterprises have, you know, proprietary concerns. Is there going to be an issue like that in this forestry domain as technologies move into it?
Yeah, I mean, the model is more likely to be software as a service or data as a service. And, you know, it's interesting because you can collect the same data and downstream 5 years later, you can figure out how to get new information. You can resell that information, even though it's the same data. So for example, you know, you might just have over the canopy flights with the LiDAR to get some estimates of how many trees there are. Then you could do under the canopy flights to get more precise information. And downstream, you could say, well, I'm going to take all that information and get semantic information, what kinds of trees, where the fork, I'm going to show my ignorance here, but where's the first fork, right? Am I getting this right?
Yep.
So you could have that information and then you could monetize it. And I think somebody was talking about, I forget in the previous panel, about identifying the type of trees, which is really very hard to do. My understanding is even experts do it by looking on the leaves on the ground as opposed to looking at the trees, but who knows, maybe you have the data and you might be able to train machine learning algorithms based on physical sampling to identify what kind of tree that is. So it's really about selling information. But of course that information needs to be updated. So I think of it more like, you know, you buy a fancy BMW or your Tesla and your maps have to get updated. You're paying a service fee. And it's a slightly different model. I think in precision farming, it's again much harder because firstly, the big companies like Monsanto and John Deere and so on, they're already invested in a certain, that's big business. But where it really pays off is if you talk directly to owners of orchards, for example. And there, it's unclear to them whether this data is going to be valuable or not. So there's a little bit of chicken and egg setting. So at Penn, we have this Center for Precision Agriculture where we're trying to work with the farmers. We're trying to do year-long experiments to show data does matter. So if those experiments are successful, then that could become a data as a service model. But I don't know that it's the model you're referring to. I think that's the old model.
Yeah.
So ultimately, I think everything will be subscription based, and I hate to say this, but it's like Spotify or Apple Music or something like that. Yeah.
And so in this data world, how do the data rights, how do you see those evolving for,
Yeah.
do the owners of the land want to keep?
I tell you, precision farming, you go to an orchard, you collect data, they want those point clouds. They know nothing about what it means, but they want it. It's theirs.
Yeah.
I think in the TMO world too, they don't want you to share data. In fact, for us as a university to go to TreeSwift and say, hey, can you share your data? Because we'd like to be able to analyze it. That would be pretty complicated.
Yeah.
So we collect our own data, which is really a shame, but.
Actually, it's kind of funny in forestry. I think that the inventory, they were so protective of. I'm like, who cares about this inventory? What
Yeah.
Russian is interested in finding out about this inventory? Also, a lot of it you can sort of figure out from existing data, federal data, NAEP data, satellite data. You can kind of see,
Right.
pretty much, which was actually my argument for GIS for them, for the company I worked for, was to say, you need to know more about what your asset is than anybody else will know by being able to look at all this free data.
Right.
So don't think, you're just holding on to all your stuff. Nobody else is going to know. It's a deep, dark secret. Because, you start selling that property, somebody else is going to be able to fly a drone or do some other kind of information. They're going to come back and say, we don't agree with this price. We don't think this volume is actually there. There's, I think that they're crazy about drones. They love drones, but they're thinking about putting it in the back of the truck and just driving out and then like shooting off the drone. And then they get the information. They don't get the concept. Somebody else, paying someone else who's not a forester, doesn't have a dog, going out there doing this. It's like, who are you people?
Right.
Are your results as good as what I could do anyway? What's the trade-off there? I think they'll go for it. It's just a matter, it's new,
But you bring up a good point. Over the canopy satellite data, everybody can get to relatively easy. It's the high resolution. Can I measure the height of the tree? Can I go under the canopy and measure the size of the tree?
Right.
And can I get an accurate tree count? I imagine that's really valuable.
Yeah.
And they want everything, the raw data to the information.
Yep. Yeah.
But information is funny. Again, you can take the same raw data and get more and more information from it. So it's unclear to me how they would view that.
But then you have to be able to project forward because your data is different static data collection points. And so they use that with their biometrics and their projections. And if you can get, and as technology improves, you get better information from, you don't want to be doing apples to grapes. You want to try to be able to get your data the same. But yeah, they want the data and be able to use the data. But actually, I was thinking about ecology though, that when you were talking about different interest groups, there's a fellow in charge of one of the areas in Canada on Planet satellite imagery, and he's a ecologist by training, I think. And he was saying that it's all well and good to be able to measure restoration, like you can have a cut and then you can measure how trees are coming up. He said, but what happens to the birds and the animals and the insects? Does that actual invite, what comes back? Does the thing that you cut out come back, or does something else come back? And those measurements, again, that's why you need somebody out there with their instrumentation and with their knowledge, being able to add that to the information that that would be relevant for climate.
And those are super hard fought data that to put field crews, for students in the field, vehicles, lodging, all of that it takes an immense amount of work. And so if we can get to the point where, let's say you do cut and you have some subsampling to know kind of the response of your system coming back. That the tricky thing is that we don't know necessarily where we're going with climate right now, or we do know where we're going, warmer. We're not always sure about the precipitation regime. And like right now, the context I work in the Southwest or in the Western US is that we're in a mega drought. And the system is changing, before our eyes right now. And so we can't even necessarily look back at the past and predict where we're going forward. So there's a lot of complications with understanding, how the system responds ecologically.
I mean, species is tough, but
yeah,
all the other critters is also extremely difficult. I mean, I think you can take care of a lot of like a tree measurement, but all that other part of it, the species of trees, is difficult, and the nuances.
Even in tree measurements, I don't think we have solutions to do physical sample measurement, which I think at the end of the day, that's what people want, whether it's ecological or so, just going up, picking up pieces, like even for soil moisture sensing, this is really hard to do.
But but a combination of all those things, soils, ecosystems, a lot in an earlier case, related to carbon. You have carbon audits that are different than inventory for volume, and so I was doing a field collection thing, and the carbon person says, well, while you're out there, because that's usually what happens, is your costs are involved in sending somebody out into the field. So the more you can get done when that person's in the field, the better. One person though can't necessarily know all the things they're looking at, or and so if there's a way to be able to kind of knit your technology such that they go out there and it's kind of like they can run this report, they can check this, they can do different things. You maximize your field worker use and data collection capabilities, and that solves a lot of problems for a lot of different people at the same time.
Yeah.
Questions from the audience?
Yeah, sure, please. Sorry, I've been so wrapped up in this conversation. I've been fascinated. If you have a question, just go to the microphone so the people online can hear you.
And George, I want to call your attention to someone made a comment in the chat from Alexander Young mentioning this company called D Leaves.
D Leaves, okay. Do I see the chat?
Is it up there?
Right. D Leaves uses their drones to collect vegetation samples for trees and forests. All right.
Yeah, I'll mention it's a company out of University of Sherbrooke.
Okay.
In Canada. And yes, they've developed a drone system that will fly around and actually can cut a sample from the tree.
Oh yeah, I've seen this stuff.
And then what's done with those?
Well, what's done with those is they provide those samples to biologists or ecologists. And I know recently they were flying in Hawaii, I believe, and they actually, and they were sampling off of the cliff. And I think they discovered a new species by bringing some samples back.
So one of the things, if you really want to do sampling, it has to be at scale. And the challenge with this is you're doing one thing at a time. Usually there's an expert saying, I think there's something important there. I want you to fetch it. And as opposed to fly through this forest or fly through this mango grove and tell me what you see. And so there's some sense of scale that I think we need to transcend that boundary if you're going to have an impact in the ecological world. I feel. So,
yeah, absolutely. And yeah, but you have to start somewhere.
Just a quick note, I mean, the hyperspectral remote sensing is getting much better and getting down to the species level. So there's a lot of, if that's what the need is, that if they're collecting leaves for identification, that's one thing. That it could be collecting for nutrients and other things, but the hyperspectral remote sensing is getting better at that.
Now, do you mean from satellite platforms?
Satellite, yeah. So that would just get the emergent canopy.
But if you're to collect it like the leaves collection of an area, and then you had the hyperspectral satellite to vary, then your training's this. You get the cross training there, and so it takes care of some things at scale.
Yeah, interesting.
Super interesting conversation. I was enjoying that. I think it's Nicole. So this question is targeted for Nicole, coming back from that context with the United Nations. between the different ways of the different weapons that we have to use in forestry to fight climate, conservation, reforestation, afforestation, or IFM, improved forestry management. What do you see as really promising here to do some good damage? Which one do you think is something we really need to like double down on more than we are?
And the typical political response is that all of them, that because there are some areas, like I said, that 70% of the land surface that's been altered, there's the other percent that we really need to be thinking, the other 30%, we need to really be thinking about getting into conservation. And so, and there are efforts and targets going toward that. But then when you have, cropland systems, and that you need to start building solar carbon, and you would really need to be focusing on something very different in a cropland system versus a grazing land system. So I would say that those different strategies depend on what land use your land is in at that point in time. And yeah, and I think that's the most important thing. So for cropland, any agricultural system, you want to be really focusing on sustainable or integrated forestry management and sustainably managing those lands with whatever weapons that you have. So that, I hope that answers your question, but yeah, I think it will take all of those approaches.
Thank you. Yes.
Yeah, I have maybe a couple of things. Also a question probably for Nicole. So when you talk about restoration, I have a broad understanding what that means, but we are roboticists. Can you maybe give us some concrete things as to what that involves? Like what do you see? Well, what does it mean? Like what practically are we talking? Well, what are we talking about? Robots that are going to be planting trees? Are you talking about robots that are just going to be taking samples? What are some of the tasks that are involved in restoration? That's my question.
Yeah, that's a great question. And I think the easiest answer I can give is the system that we're working in for our project that's funded by the U.S. Department of Agriculture. So we're, and you can apply this to forestry also, to forest ecosystems, but we're specifically working on in overgrazed, highly degraded rangeland systems. And so what we know is that business as usual approaches where we go out and spread a lot of seed, or even we disturb the soil to plant seeds, often fail. More recent paper that came out is that 17% of those seeding projects where you're spending a lot of money on seed fail. And then the rest of them, those projects, they can succeed in the first year or two, and then you just see a decline in what you seeded. And so those are not very successful. So what we're trying to do, and this is where our project comes in, is rather than what that seed sees, like if it sits on the end of your fingertip and it's that small, what that seed sees is not a landscape. It sees a very small microsite, a centimeter around it. And so our idea is that we're using robots to simultaneously sense and map the site for optimal seed placement. So what are areas that, for example, if there's like a dip in litter that can serve as a mulch, plant a seed there. Or if there's a crack in the soil, we know that a lot of plants can come up there, and so we plant a seed there. So it's kind of precision restoration, if we want to spin off the precision agriculture. And so that would be one way that I can really see that we're harnessing those technologies to say, okay, we're not going to just randomly just be spending money all the time for failed projects, is that we're going to start really targeting certain parts of the landscape where we know reseeding native species will likely be more successful.
Okay, all right. And I have another comment, if I may. So, Elizabeth? Yeah, right. So you made an interesting comment. You said, well, if you're going to send somebody out in the field, you really want to maximize what they can do. And it made me think about, well, it's not just about, well, what the robots can do, but it's also providing assistance to the human, right? So providing them with better devices, providing them with better instruments or sensors or loggers, or I don't know what. So kind of more, to help the person that you're sending out to do better, to be more effective, more efficient. What can you tell us about this? Do you see an opportunity here? What technology people like us could do here?
Well, a couple different things. One is that, like I said before, about the long learning curve for GIS. A lot of technology came along, like iPads, iPhones, satellite imagery. All those things happened during the process of building up the GIS. It used to be you had to build the database. You didn't have any base maps. You had to go out and buy from USGS topo maps. But all that became much more with the formation of base maps. Okay, so now there's technology that they have. When drones first came out, foresters were running around trying to figure out how they could use them because they thought they were so cool. But I think that if there is a way to be able to make it accessible to an individual, the technology, that might be something that they could grab onto. But if they don't do it, in a sense that it's not just throwing the drone up there and saying, hey, because one of the things I was also aware of is that looking at data is different than having looking at trees. Flying through trees does not solve a problem. Getting the data about that trees, that you've got to have numbers, that solves problems. And so they've been kind of preoccupied with going around and seeing things, boy howdy, and a little less so about what you're actually collecting and can use. And so I think that if you can come up with ways of being able to demonstrate how you can collect this data and it makes a difference in your management of the forests, that's. And you were saying like software as a service. If you're going out there and you're throwing a plot down for a carbon inventory, which is completely separate from a forest inventory, if there's some database that it then gets fed back up to, then that's helping them. So if that makes any sense. But I think that the more technology advances they're going to be and the more tools they have in their toolkit, the better off they'll be.
So a question for Vijay. How much do you think the self-driving car is it's attracting a lot of talent? How much this forever sinking of talent is stunting the growth of other sectors like forestry and restoration, because either of the salaries or just this attraction of the holy grail, how much is it hurting the rest of the ecosystem?
Yeah, it's a great question and something, when I gave a plenary at ICRA a few years ago, I lamented this and I said, when I first started in robotics, it was the other way around. We're developing all these cool things nobody's interested in. Now we're complaining we're developing all these cool things and taking all our talent away. So you can't win, can you? But I got to be careful because you look at the sponsors here, we have a record number of sponsors, self-driving companies that you would not have heard of 3 years ago that are now part of you. So there is some benefit to that. But again, I have great confidence in the next generation of researchers, citizens, I'd say, politicians who would be influenced by citizens. I think big tech is in for a big rocky ride. I don't mean this in terms of capital markets. I mean this in terms of the public sentiment. We're seeing this in the UK and Europe, much more in the US. And so ultimately, I think talent will not want to go where the money is. I think everybody wants to have impact. And the 21st century challenge is climate change. And I think people will rally around that. So yeah, we're going to complain about this. We're going to complain about salaries. Why do professors make more than high school teachers? High school teachers should make as much. And there will be inequities in the system, but ultimately I think, and I'm seeing this in my lab, they love forestry. They love agriculture. They don't want to do defense, for example. And these are smart people. It's not, I don't know if you're seeing the same thing
I
at
see
Carnegie.
exactly the
Yeah, yeah. So, and everybody wants, I got funding for 2 students, but the 10 students working on this project, I have no idea how to fund them. And so I feel good about our future, despite the challenges and the dire warnings that we just heard from Nicole. I do think we'll rise to the challenge.
No, I think that also, when you said not for defense, but a lot of technology came from defense, whether we liked it or not, in terms of, things that are used like GPS or whatever, those were all defense funded
Yeah,
things. But I think,
yeah.
you're right, that because, now you have a SpaceX, you have some billionaires out there that can actually do the space program without NASA. So it's kind of like, well, that is a shift. And it's shifted away from always assuming that your government is going to put the money, whether it's defense or not, that is actually coming from individuals. I mean, Tesla just thought nobody was into electric cars, it's crazy as the owner may be. It's just, I think you're right, there's much more interest in and much more capability out there to do things, not necessarily for defense or for specific, that there's opportunities everywhere financially for the growth of the
All right, so I'm going to ask one last question to wrap things up. I'm really curious about this. I've spoken to you about it individually, but can you just, like, we've heard a lot of talk loosely about carbon and carbon audits and carbon markets. Can you try to give us a little bit more detail on what that means and where you think it's going, and specifically how these technologies play into that?
Is something you want to talk to?
I'll let you start. Probably in the carbon.
By the way, you don't have to be right. I just want to know what you think.
I just think that in the carbon world, as we were saying before, that it's the Wild West out there. And that if you have a lot of money and you have obscene amounts of money and just money chasing solutions to be able to put into carbon, there aren't enough forests to take care of our carbon sequestration problem. And so I think that there's going to come a point where the entities that are buying up the carbon credits are going to realize they've run out of forests to sequester carbon in, and that hopefully at that point, if we're going along, we're going to have much better measurement capabilities, because right now I think that there's sort of a there's a general verifiability of what these measurements of carbon tons is, but that measurement needs to improve, which I think in terms of robotics, that would be the case, because there's sort of a lot of estimation, I think, at how many tons of carbon are sequestered and managed, but it's definitely got room for improvement. And I think that the auditors and the bigger money financial institutions are going to want to have much better verification of what they've put their money in. But that's just my hope.
No, I could not agree more. I think there's a lot of speculation about, well, I'm going to offset my carbon footprint this way, and you have no idea how they're doing it.
Yeah.
And so I think when you have, there's a challenge here, because we would love to say that robotics is a gold standard. We're going to measure this to some nanometer resolution, and this is it. But the world has to accept that, right? So I think it's one thing to say the management companies, the harvesting companies will accept it. But it's another thing to say that insurance companies or the financial institutions are going to accept it, and then the politicians eventually. So I think this will take some time, but I don't see any other solution really for this. I think this is huge. All the big tech companies are as invested in this as they are in self-driving cars and all the cool goodies that we'd love to see. So that again gives me some confidence that we're going to see the needle will move in the right direction.
Anything to add?
Yeah, I think, so we've talked a lot about trees and trying to estimate above ground carbon, but one of the key challenges is all that carbon that's being pumped below ground
Yes.
that we cannot measure.
Yes, that's
well.
true.
Mhm.
And so when I think about above ground carbon, I'm like, that's easy. And which it's not compared
Thank you.
compared to below ground. And that's where there's a lot of junk models out there to estimate soil organic carbon, because that's really where you want to start pushing carbon in these systems, is that, you can have a fire, and which we're seeing a lot of fires, take out all your above ground carbon and just blast it back into the atmosphere. Is that we want to be thinking about how do we sequester carbon into longer term pools, and how do we measure those incremental
totally.
changes. So that's my carbon comment.
Excellent. Well, thank you.
But one other thing linked to that, if I may add, I think the other thing is about firefighting. I think, we fight fires because we think, of course, we want to fight fires, we want to preserve trees, but at what cost? And then, so what fires do you fight if you have limited resources? We don't know how much carbon is where. So I think in strange ways, that might also play a role, right? So our whole strategy is to how to mitigate this. I think we'll have a much better strategy if we have data. We don't have that. Yeah, so sorry.
Sorry, no, just to add on top of what Nicole's saying with soil, there's a recent study, super recent, that is showing in one case, the carbon afforestation, reforestation, all this great biomass above the ground, net zero carbon, because they as soon as they measured the soil and how it affected the nitrogen cycle underneath, it actually sucked all the carbon from the soil in a terrible way. Now they're expanding on that to see how widespread is this. But really alarming, really concerning about, is afforestation actually a net additive, or is it just bringing that carbon out to the over soil, over the ground? So it's super important, like half of all of this, right? Like,
Yeah, it's not only how much, but like where it's stored, and is pretty critical.
All right. Well, thank you all very much. This has been a very exciting discussion. So
Thanks again for organizing this. This is very timely, and I hope next time we do this, there'll be 10 times the number of people.
I agree. And so since we're wrapping up, I'll just point out, Francisco, can you stand up? Francisco did all the work.
Yeah.
It was great to sort of get to know this community, help, maybe this is a nascent community. I met a lot of new people, a lot of exciting new ideas. So like Vijay said, let's keep it up and let's grow. And there's a ton of really interesting problems here, and there's important work to be done. So let's do it.
Bye-bye.
Antonio, you want to say something? Antonio, I think, was just saying thank you.
Bye.
Appreciate you guys hanging out on Zoom. Thank you.
You're welcome.
Thank you for having us.
Yeah. Bye-bye then.
Bye.